So it's my pleasure to introduce you to Bill Laboon from Polkadot. Please a round of applause. He will be sharing some insights on smart contracts on Polkadot. Can we maybe turn the screen to the next panel? This topic is particularly relevant as we think about the future of cross-chain operability and blockchain in general. And he's also going to cover on how projects can evolve from building on Polkadot Hub to creating their own parachain on what Polkadot calls the cloud model. So thank you, Bill, for being here, and I hope you all enjoy this talk. Thank you.
Thank you very much. Let's see if this works. Yep. Hi, everyone. My name is Bill Laboon. I'm from Web3 Foundation, where I'm Director of Education and Governance Initiatives. So today, I'm going to talk a little bit about smart contracts on Polkadot. Maybe. How do we get to the next slide here? Yeah, it's just very slow. All right. Or maybe should I go over to here and press the space bar when I'm ready? I need to, okay. So you can tell that I'm not a hardware guy. I come from a software engineering background, obviously. So a very quick background for people that aren't familiar with Polkadot. It's what we call a heterogeneously sharded blockchain. You can think about it as just a whole set of rollups that are automatically verified in a decentralized way by what we call the relay chain. So there's one chain that basically supports a lot of different rollups, can support hundreds of these rollups, and they're automatically verified and not done through a centralized sequencer or anything like that, and they can all interact and communicate with each other. So kind of a cool system. Excuse me. I'm a bad aimer, apparently, too. So using the Polkadot SDK, anyone can build their own rollup and connect to the Polkadot, what we call the relay chain, this main chain. Have the ability to have assets from one chain interact with assets from another, or a smart contract on one chain call a smart contract on another. And we actually have 43 of these what we call parachains. These again, you can think of them as kind of like enshrined rollups, if you've heard that term before, already active on Polkadot. There's actually a lot of other chains out there that behind the scenes are using Polkadot technology. So Substrate, you may have heard of, is part of the Polkadot SDK. It lets you build your own chain. So just a couple of examples of these other chains that are not on Polkadot, but are built using Polkadot technology out there. And there's a reason that, or actually many reasons, that so many different teams are building on Polkadot and just using the technology. The technology is really awesome. It's built with Rust. So if you're using Rust, you want to build your own chain. It's extremely easy. We've got templates out there. So you can make your own chain very quickly, as long as it takes to compile it, which, to be fair, compilation takes a while right now. But you get GitHub, download it, the Open Zeppelin template, you can have your own blockchain running in 10 minutes or so, which is kind of cool. Right? There's built-in security connecting to Polkadot. You are sharing in the security of that relay chain. Very easy cross-chain interactions. This is built in using a technology called XCM. And we have channels that are open. You can have, again, an asset from one parachain move to another parachain, use it there. This could be any type of asset, NFTs, call different functions from different chains, et cetera. Relatively low block time, 6 seconds. Right now, this can go down to 2 seconds using a technology that you have to activate called elastic scaling. And actually in testnets, using some more advanced forms of this elastic scaling, we've gotten that down to 500 or 600 milliseconds. So really fast blockchains, really fast block times, really cheap transaction fees, stablecoin transfers right now, for instance, so not native tokens, but USDT or USDC, are 6/100ths of a cent in US dollars. Extremely high scalability. So we had an event called the Spamming, where on Kusama, our canary network, we said just how many transactions can we run through, and at its peak was 143,000 per second. Really high decentralization, Nakamoto coefficient of 143. That means that 143 entities would have to coordinate in order to cause problems with the relay chain. And it's very much in my interest, the world's most advanced on-chain governance since 2020, is using a system called OpenGov. So this all sounds awesome. I realize I sound like a salesman here, and I'm an engineer. So let me say that, like, yes, this is really great, but it is not perfect. There definitely have been some problems with Polkadot. There are things that developers have told us they wish they could do that they can't. And so, we've listened. Both the Polkadot, the Polkadot ecosystem has listened and has developed a plan, going forward to fix it. So, what is this problem? And right now, we have this amazing technology. I really do think it's amazing. And like I said, it's not just me saying that. Lots of other people that aren't building on Polkadot are using Polkadot technology to build their own chains. So we have this big choice, though. If you want to build on Polkadot, okay, you build your own chain, which, if you want to do something specific, can be very difficult. It requires some infrastructure. It's a lot of ongoing work to make sure that a chain is running. It's not as much as developing your own solo chain, but it's still work. Or you choose one of the many parachains in the ecosystem to build a smart contract on. So some of these chains allow you to create a smart contract. So for instance, Moonbeam, which is an Ethereum-compatible chain on Polkadot. Others don't. So for instance, Zeitgeist is a prediction markets parachain. It is just for their prediction market app. It's an app chain, essentially. So you have to choose, what do you want to do? Do you want to build a smart contract on one particular chain? And then the question is, all right, well, which one? Or do you want to build your own entire chain, which might be overkill for what you're going to do, may require a lot of work. It's more difficult to build a runtime than a smart contract, because at the runtime level of a chain, there are a lot fewer guardrails against causing problems. So it's difficult. People always ask me, when I was first talking about Polkadot, and they say, well, how do I get started building a smart contract on Polkadot? It's not that simple, right? There's additional steps. Polkadot itself generally did not run smart contracts. So there's generally a steep development curve behind building on Polkadot. A lot of really powerful technology, but I'll admit here, I use a very old text editor called Emacs. So if anyone's familiar with Emacs, or maybe Vim, you can also take that. I think of Polkadot as like Emacs or Vim. It's a very, very powerful text editor that has a lot of work involved to get good at it. And this is really reduced, I think, like super fast iterative development in the ecosystem. People just coming on, trying something out, seeing if it works, and then building from there and see if they have product market fit. So the solution is something that really should be the goal of any of us here as developers and people developing products for developers, is make it easy for devs, no matter what they want to do. Like, this is not easy for me, but so what we came up with is something called the hub and cloud model. So essentially, this is dividing what you can do with Polkadot into two parts. So cloud is what you could always do. If you want to build your own chain, an app chain, you have your own idea for a smart contract chain, like that has a particular smart contract programming language, or your own virtual machine, or whatever you want to do, you can still do that. You can use the Polkadot SDK, you can connect to the Polkadot relay chain. But we wanted to give the other option for people that are first starting out, that may have something simpler that needs to be done, that want to iterate more quickly. And this is Hub. So Hub is going to let you do everything else. interact with these rollups, interact with Polkadot as a whole, the various chains, and deploy smart contracts. So these are essentially native smart contracts to Polkadot. The way they operate behind the scenes, we'll talk about in a moment. It's not exactly a quote-unquote native smart contract on Polkadot, but it is essentially a native smart contract on Polkadot. So with this, you can do anything in the Polkadot ecosystem. So besides building your own chain, which I said we're already covering under this cloud model, anything else that you want to do can be controlled by smart contracts. Anything on any of these chains. So think about having, again, using Ethereum as sort of an example, having a smart contract on the main chain of Ethereum, on the L1, that can interact with any of these L2s seamlessly. Get information from them, call smart contracts on them, send assets, doing this all seamlessly. So anything that you want to do, creating your assets, interacting with governance, sending and transferring DOT or other assets from one account to another, setting your identity, apply for treasury funding. There's all kinds of different things that you can do in Polkadot that now can also be controlled in one place via smart contract. All right, so let's dive a little bit into the details. Right. So remember I said this is not exactly native smart contracts, because there is, again, this relay chain, this base chain, and the whole goal of this chain is to not have any transactions on it. So that's why one of the reasons I always think it's funny when I see people talking about like transactions on Polkadot. Often they're just looking at the relay chain. And I say, well, the more transactions we have on there, the worse it is for us. Really, everything should be done on these rollups. You shouldn't have anything be done on the relay chain, because the job of that is just to coordinate these rollups. So we have a particular system rollup we call now the Asset Hub. That will just become a hub, which is going to get some additional features which will allow these smart contracts to run, and they will be essentially native. Yes, theoretically, behind the scenes, they're running on one of the parachains, but it's set aside as the one, by default, that smart contracts will go onto. If you have ever programmed in Solidity, this will be, it's hard to snap your fingers when your hands are full. There we go. This will just be a snap, right? It will just be everything you're used to. If you've worked on any EVM-compatible chains before, all of the tools work automatically, all the RPC endpoints, it's straight up EVM compatibility, or excuse me, straight up Solidity compatibility. So any of the Solidity tooling you're already using, you can use. So this gives you, without changing your stack, you get all of the other benefits that you get with Polkadot. So all of these other things, like this extremely fast block time, again, 6 seconds right now, up to 6 seconds by default, 2 seconds with elastic scaling. In test nets, 500 to 600 milliseconds, as we're working on some other, some newer technologies. But you can do this with Solidity. You can interact with other chains, just using Solidity. You can do anything, you can control all of this other data, read all of the data from all the different chains, just using Solidity. Third time's a charm. Okay. There are some additional precompiles that are being added to this that will make a lot of cryptographic functions faster, as well as some other capabilities for interacting with other chains. So you'll notice, I said you can use Solidity, and I'm talking about that this is EVM compatible, because behind the scenes it is EVM-like, but it's actually not an EVM. So it's something called the Polka VM, which is a RISC-V based virtual machine. So this is a replacement for EVM. It's very similar in terms of the interface, still has metered transactions, but behind the scenes it's RISC-V based, so instead of being stack based, it's register based, which means it maps very well to physical hardware, which end result of that is just that it's extremely fast to execute. So if you look at some of the, and I'm happy to share, I probably should have put a graph up here, and I just totally forgot as I was writing this. But I'm happy to share if anyone wants to get specific numbers on this. It actually is very close to the speed of just executing similar code like on the bare metal, like 1.67x or something like that. So extremely fast to execute, which means that you can do lots and lots of stuff, right? In much more stuff in the same amount of time, since all of the nodes that are running it are going to be able to execute much more quickly and much more efficiently. Extremely fast to compile. It's got the guaranteed single pass ON compilation, which just means if it's n bytes long, then if you remember your computer science classes, right, it just goes through once. It's not going to be, unlike some other languages, it's not going to take a very long time to compile. And as the program size increases to compile, as the smart contract size increases, it's also the time will only increase linearly. So secure and sandbox, fully deterministic. A lot of the benefits of EVM, but just much, much faster and much more made for the physical hardware that we have today. A couple of other things. I mentioned the relay chain as part of this process. I had mentioned the relay chain. The fewer transactions, the fewer things that are happening on there outside of rollups, the better. We're actually moving more things over from the relay chain to this hub parachain, which again is going to make things much more efficient. The relay chain should be focused on supporting all of the various rollups. So this will also mean transaction fees get lowered even further. Polkadot has something called the existential deposit, which is an account needs to have a certain amount of a token in it. Usually DOT, it actually can be other tokens like USDT or USDC. That's getting reduced even further to 0.01 DOT. So basically everything is getting faster, everything's getting easier. But still you can use your regular old Solidity stack. We are also adding in, as part of this, the Hub API. So what this means is that a single API endpoint that also can be accessible by these smart contracts, as well as just through RPC if you just need to read some data, will provide one single API for reading state across all of the different chains. So there's all kinds of different chains in Polkadot, some of which are system chains like identity. It has identity, a core time for this coordinates the ability for these rollups to access the relay chain, et cetera. All of the data from across all these chains, all these third-party builders building on top of Polkadot will all be accessible through the same API. So the idea here is abstract chains away from developers. The developer, if they want to build something and they want to use something from parachain A, rollup A, and something from rollup B, something from rollup C, they should be as much as possible able to do that all together without thinking through, all right, well, this is on this chain, this is on this chain. Just find one place to find all of this data, grab it, and do things with it. The final great thing about this is that there's a very easy migration path. A developer can come on, start making a smart contract, realize they need their own chain, just move to their own chain using that same smart contract, and if they need to continue with building directly on Substrate, Polkadot SDK, and making something even more specific for their particular needs. So the great thing about here is, as developers always should do, start small, iterate, move to what you need to move to. Okay. So in general, the smart contracts on Polkadot really are more than the sum of their parts. Because not only are we adding all these benefits of faster, better, more efficient smart contracts, we also allow them to easily interact with all these other chains and utilize them together and in different ways. Okay. So hopefully, again, this is a very brief overview. Just if you're interested in building on this, it's already open on testnets. Kusama, which is our Canary network, it is coming out in the very near future, probably late April, and then in Polkadot a little bit later this year in Q3 of 2025. So thank you all. If you see me around, I'm happy to answer questions.